It depends on you. What grade do you want? Okay guys, I had no scheduled live today. I just thought let me just come in here because I've got some time to spare. Probably in the next hour I will 11, please, term 2. Okay, which topic? Because in grade 11, term 2, we've got Euclidean geometry, we've got functions, we've got analytical. Party guy. I'll do grade 11, term 2. Actually, let's just continue with functions because I started out with functions. Oh, geometry. You want geometry? You want geometry? Okay. Let's look at geometry then if you want geometry. So firstly, hopefully we can establish that you know what was happening in geometry in the previous grades, because that's very important. So if you want to establish the geometrical sweetness, then that's fine. Okay, let's look at it. Let's check him out. Hey, Kiabeto, will I be live at night? Yes. I'll attempt at going live at night, hopefully. When you say at night, what time are you talking about, roughly? Hey, iyawuxhomekeka. Ingxaki mem iyawuxhomekeka phaa ku-principal. Okay. okanye angayotshekisha wethu ulantuka. Makatshekishe phaa makaye kulaa klasi aqhele uya kuyo kusayensi atshekishe phaa. Yeah. So give it what time, by at night, what time do you mean? I'm trying to establish that. Okay, so grade 11 Euclidean geometry, guys, has to do with circle geometry. Okay, so we need to know first and foremost what are the different aspects of a circle. We need to know the different aspects of a circle. All right, so first and foremost, you can see most the circle is not as perfect as you would like it to be, but something to note is that this here, the circle, we know that this is a circle. The distance around the circle, we refer to that as our circumference. So this is called a circumference. Then there is something that we refer to here as the center, okay, of the circle. So this dot here will represent the center of a circle. Then from the center to the circumference, there is a line that we refer to here, and when we label it, we call this line from the center to the circumference, we refer to it as the radius. Okay, yeah. So far we've learned about the circumference, which is the distance around a circle. Then the center, which is specifically the point midway of a circle, which we refer to as the center. Then from the center to the circumference of the circle, there's the line that joins the center to the circumference, we refer to it as the radius. Okay. Then we have another line which comes from one end of the circumference through the center to the other end of the circumference. We refer to that line as the diameter. Oh wow, Draco, thank you so much for that. You're very much unexpected. Thank you for the paper crane. Okay, so we refer to this as the diameter. Okay, so the diameter cuts the circle into half. It's the line from the circumference through the center to the other end of the circumference. We call that the diameter. Okay, thank you so much for your kindness, Draco. I really appreciate it. Then a line from one end of the circumference that doesn't pass through the center from one end of the circumference to the other, we refer to that line as the chord. Sure. C-H-O-R-D, the chord of the circle. So this is the chord. This here is the diameter. Yes, it is the line that's from one end of the circumference, but what is special about this specific line is that it passes through the center. So we refer to it as a diameter. So you could say a diameter is a special chord because it is a line that passes through the center. It comes from one end of the circumference to the other, but it passes through the center specifically. So we refer to it as the diameter. Whereas here, this line comes from the circumference to the other side, and we refer to it as the chord of the circle. Okay. Now, the other thing as well, I just want to so this here, guys, what you see here, you see these stars that I've actually written here. We refer to this section or this portion, we refer to it as a segment. All right, segment. Okay, so this portion or this space, this area, okay, it's closed by the chord. We refer to this area. Let's say this was a pizza, like if I decided to cut it through this way and I took this slice, this is a segment of my pizza. So the segment of a circle, this would be this area, all right? We refer to it as a segment. Of course, you can see that this is like a small segment, but remember, let's say this line, if I looked at the right-hand side, this entire big piece, all right, this area, let's say I shaded this entire area, okay, there's this area with the star, we refer to it as a segment. Then there's this area on the right, okay, which does not have the stars. The entire area, we would also refer to that as a segment. But this one is small, so we refer to it as a minor segment. And then this portion where the chord cuts here, this portion, this side, we would refer to it as the major segment. All in all, guys, they are both segments, okay? All right, so basically a segment is that area that is basically divided by chord, right? We call that particular area as a segment. Then I'm sure you guys can see this. This would like be a slice of pizza if you're talking about it that way. From the center to the core, to the circumference, and from this center to this circumference. Obviously, these two are called radius. We have radius, okay, that are here. But then this slice of pizza, we refer to it as a sector. A sector, okay? So we've got a segment and we've got a sector, right? So a sector is basically that area or that portion that is basically existing because of the radius, right? So we refer to this as a sector. So your slice of pizza, when the next time you actually have a slice of pizza, just remember you are eating a sector of the pizza, all right? We never say that we are eating the segment of a pizza because your pizza will never be cut in this way. All right, so basically, I hope you guys understand that, okay? Right, so like I said, first and foremost, what did we say? What did we learn first and about? We learned about the distance around the circle. We refer to that as the circumference of the circle, okay? Then in the middle of our circle, we have what we refer to as the center of the circle. Then if we drew a line from the center to the circumference, we refer to that line as the radius, okay? One radius, okay? That's singular, one radius. Then the line from this part of the circumference to the other end of the circumference, we refer to that line as a chord, all right? Then the line that passes through from the circumference through the center to the other end of the circumference, we refer to that as the diameter, okay? So these are basic concepts of a circle that we need to know before we dive into the actual theorems that basically in grade 11 geometry we cover. So we need to at least know these basics. We need to know what a diameter is. We need to know what a radius is. We need to know what a center is. We need to know what a segment is, all right? The area, like I said, the area. We need to know what a chord is. Now, there's something else that I also want to talk about really quickly, all right? This portion of the circumference, so if I look at the distance from this point of the chord all the way around, traveling on the circumference to the other part of my chord, we refer to this distance. Obviously, this is all around, this is my circumference. But if I take a section of the circumference, we call this a arc, A-R-C, okay? It's a section of the circumference. We call it an arc, okay? So this would be an arc from here all the way to there. We refer to that as an arc. From here all the way back to here, that would also be an arc, okay? So these are important concepts that we need to learn, which are basic to our grade 11 theory of Euclidean geometry. You know, if we know these basic things, what a center is, what a radius is, what a circumference is, what a segment is, what a chord is, what a arc is, then it facilitates or makes it easier for us to be able to then look at the different theorems that we have in Euclidean geometry and understand what it is that they are stating in each theorem. So I hope everybody now knows and can tell me what a circumference of a circle is. Circumference of a circle is simply the distance around the circle. Distance around the circle. Aisha, you can. You can ask a question about the segment. Okay. So distance around the circle, that's your circumference. Center is simply that middle point. Okay. Right? It's internal to your circle. The middle point. Okay. It's like midway your diameter. Okay. That's your center, your middle point. Radius, it's the line from the center to the circumference of a circle. We refer to that as a radius. Okay. Sector, like I said, guys, you can just say it's your slice of pizza. I know you're not going to say that in like actual terms, but I mean a sector is just simply a slice of pizza. How is it formed? You have to have a radius and another radius, and basically that entire portion or slice is basically your sector. I know this CO about angles in the same segment. Yeah. We'll get to that. Remember, at the moment, I am just simply explaining what each of these terms mean. Okay. At the moment. I'm sorry, guys. I had to actually change venue because wherever I was, there was a bit of noise happening. So I had to move and change venue. So I hope you don't mind. we are now here anyways. So as I was explaining, guys, yeah, we need to know these basic fundamental aspects of the, like I said, we need to know the diameter, we need to know what the center is. So I was just explaining circumference is the distance around the circle. Your center, that is basically your middle point, all right? Your radius, it's your line from the center to the circumference. Because remember, what did I say the circumference is? It is basically your outer edges of the circle. That's your circumference. Your distance around the circle, your outer edges of the circle. Then, like I said, your radius from the center to the circumference, that's our radius. Then you have your sector, like I said, your slice of pizza there. Then your diameter, that is your line from one end of the circumference through the center to the other end of the circumference. Then your chord, guys, is your line from one outer edge. Okay, doesn't have to necessarily pass through the center. A chord is just simply a line from one end of the circumference to the other. Your diameter is a special chord because it is a chord that passes through the center. But a chord normally just comes from one end of the circumference to the other end of the circumference. Okay. Then your arc, like I said, that basically becomes your smaller distance of your circumference. So if you just take a portion of the circumference, okay, enclosed, of course, here you can see by this chord, then this basically is an arc from here all the way to there. That's an arc, all right? Then, of course, if we were to look at this area or this portion, we refer to this as a segment, okay? The reason why we say it's a minor segment is because it's a small segment in comparison to, look at this area. If I was to shade this whole entire right area from this chord, this basically here inside refers to a segment that is a bit bigger than this one. Okay, so we call that a segment. So all these basic things here, very, very important. We must know these basics in order to then be able to develop our understanding of the individual theorems. Okay, so now I'm going to start looking at these individual theorems. We're going to look at the wording, and then we are going to look at the diagram and see what the wording says about the diagram, and then see how we can apply the theorem to respective problems. We'll do that a one by one. Okay, so our first theorem that we have, okay, so I'm not going to necessarily say this is the first theorem, second theorem. I'm just going to write down theorems, and then I'm going to explain what those theorems actually mean. So what is nice here is that there is a document that is utilized, okay, that is called a document for acceptable reasons. Whenever we are dealing with Euclidean geometry for grade 11, in actual fact for grade 10 and for grade 12, there is a document that is called the document that has the acceptable reasons for when we are doing Euclidean geometry. So that document is very, very helpful, all right? So we're going to look at the individual theorems as per what that document says, all right? What that document states. Okay, when it comes to circle geometry. Right, so just patiently, if you can just wait for me for a sec here. All right, so here we are. So the first theorem says the line from the center perpendicular to the chord bisects the chord. Okay, so I'm going to repeat this. It says the line from the center perpendicular to the chord bisects the chord. So let's look at this. The line, okay? Hopefully we all know what a line is, guys. A line, okay? But then it says the line from the center. The line from the center. And then it says perpendicular to the chord bisects the chord. So let's see a visual of what we mean by what this theorem is saying. So first and foremost, obviously this is within a circle because a line from the center. So let's put in the center here because we know what a center is. But then it says a line from the center. So I've just drawn a line from the center. But then what does it further on say? The line from the center perpendicular. What does perpendicular mean? It means that this line from the center must be perpendicularity. Has to do with the fact that this line here, which we can refer to as a chord, this is chord AB, and let's say this is center O, okay? So this theorem is saying the line from the center, there's the line from the center, perpendicular to the chord. So when this line from the center meets the chord, it makes an angle of 90 degrees. That is what is given. The line, okay, from the center perpendicular to the chord. So this is what we see in our diagram. A line from the center perpendicular. AB is called a chord. Why? Because it's a line from one end of the circumference to the other. All right. So a line from the center perpendicular to the chord. That is what we know. That is what is stated. What is the result of such a line from the center being perpendicular to the chord? What is the result? The result is that line from the center perpendicular to the chord, what does it do? It bisects the chord. It bisects the chord. What does bisect mean? Bisect means cut into half. Bisect means cut into half. Right. So the line from the center perpendicular to the chord bisects the chord. So this line, in other words, let's just say this is M. What this theorem is saying is that if AOM, in other words, the line from the center, OM is the line from the center to the chord. If OM is perpendicular, and this is the sign that we use for perpendicular. If OM is perpendicular to AB, what is AB? AB is the chord. Then what do we know? We know that, what is the result? If OM is perpendicular to AB, then what is the result? The result is AM is equal to MB. In other words, this line bisects the chord. What did I say bisect means? It means that AB, sorry, is cut into half so that AM is equal to MB. So, beautiful people, this means that whenever I see a diagram with this condition of a line from a center being given as perpendicular to the chord, a particular chord, then it means I can always state this result. To a diagram like this, I can always say the chord is cut into half. In other words, AM is equal to MB. And that's very important to note. I can always say that. Okay? The result is that AM is equal to MB. Whenever I see a line from the center that is perpendicular to the chord, that means that this particular chord is bisected by this line from the center. That is always the case. This is a theorem, and it is true in all situations where we have a circle that has a center, that has a line from the center that is perpendicular to the chord. It then means we can always say AM is equal to MB, AM is equal to MB, AM is equal to MB, or whatever the other alternative diagram actually is. So imagine now, guys, if I had a diagram like this. There is a chord, there is a line. Let's say this is N, M, C, O. You know this. Question is, what do you see? All right, so please, guys, don't mind my romantic circle. This is a circle, right? Okay, and please, let's just imagine it is, because this is freehand. NM is a chord. OC is a line from the center. And what do we know about this line OC from the center to the chord? It is perpendicular to the chord. So knowing this, what can we then conclude? We can conclude what exactly? If the line from the center is perpendicular, guys, to the chord, we know that the chord does what? The line does what? It bisects the chord. The line bisects the chord. So that means what? If OC is perpendicular to NM, this being a line from the center, perpendicular to the chord, what do we know about the line NM? What's happening there? It would mean we can conclude that NC is equal to CM. We can conclude that. Why? Because this is a line, it's from the center, it's perpendicular to the chord, so we know that that line from the center perpendicular to the chord, what does it do? It bisects the chord. In other words, it cuts that chord into half, so that NC, we can conclude, is equal to CM. Now, it's very important that for this theorem, the reason that we use is the following. Line from center perpendicular, and we write the symbol perpendicular to chord, and that would be our reason. Our reason is in the diagram. Our conclusion or statement is not seen in the diagram. So the statement that NC is equal to CM is not something that you can see in the diagram. But the reason that you write out for saying NC is equal to CM is actually available in the diagram, because you can see that, oh, the line from the center indeed to the chord is perpendicular to the chord, which is why you give the reason. Line from center, you write the symbol perpendicular to chord, and that would be very much on point. Okay, so this theorem is very important because, one, as it states, we need to first understand each word in the theorem. That when they say the line from the center perpendicular to the chord bisects the chord, we understand that, oh, a line from the center perpendicular to a chord. We know what a chord is now. We know so well what a chord is. We understand what perpendicular means. Perpendicular is when two lines meet and form the angle 90 degrees. So all of these things we understand very well. So a line from the center perpendicular to the chord bisects the chord. So if that line from the center is perpendicular to the chord, then we know that the result is that that line from the center bisects the chord. So in other words, NC will be equal to CM, NC is equal to CM. In this diagram, the line from the center perpendicular to this chord, the result is that that line from the center perpendicular to the chord, it bisects the chord. Therefore, we know that we conclude and say AM is equal to MB. And what would be our reason? It would be line from center perpendicular to chord. Okay, so it's very important. That is our theorem number that we need to know. This is the diagram, guys. The diagram is of this nature for that theorem. Okay, right. I'm going to do another theorem that has to do with a line from the center. The next one says the line from the center to the midpoint of a chord is perpendicular to the chord. So let's check this out again. What is this saying? The line from the center to the midpoint, midpoint of a chord. Okay, let's look at the statement again. The line from the center to the midpoint of a chord. So let's just look at the diagram as per what the statement says. So we have a circle here. The obvious center is there. Okay, then what are they saying now? They are saying a line from the center to the midpoint. You see how different the statement is here. It says a line from the center to the midpoint of a chord. So this obviously is a chord. This line from here to there, that is our chord. So let's just say it's chord AB. Let's just use AB. O for our center, and let's just use another letter here. Let's say M. Now from the statement, this is my drawing, the if part of the statement. Let's just go again. It says the line from the center to the midpoint of a chord. So if you are looking at this chord, we are looking for the middle point of that chord. Obviously, if they are saying the middle point of that chord, that would stand to reason that it is given to us that AM is equal to MB. So they are saying the line from the center to the midpoint of a chord. What about it? What about it? So in other words, if AM is equal to MB, that is the if part of our statement. If AM is equal to MB as per given in the diagram, then what is the result? What is the outcome of AM being equal to MB? Then we know that we can say the following: OM is perpendicular to AB. That is the result. We can say OM is perpendicular to AB. All right. Hey, I repeat, the line from the center to the midpoint of a chord. So this line is from the center to the midpoint of a chord. The minute they say to the midpoint of a chord, that is basically stating that AM is equal to MB. The if part of the statement is that if AM is equal to MB, then what? Look at the then part, the result. What is the result? The line from the center to the midpoint of a chord, what does it do? Is perpendicular to the chord. That is the result. That's why we say then OM is perpendicular to AB. So once again, the condition. What is the condition? The condition is that AM must be equal to MB. What is the result? The result is that OM is then perpendicular to AB. It means I can tell you what the angle is here and I can tell you what the angle is there. I do not see the result. What I see is the if part. I can see the if part, but I can't see the result in my diagram. All right. So that is why, guys, even if you are given a diagram, you can see the if part of the diagram. When you know your theorems, the statement of each theorem, you know the result of each statement, then you should be able to write the right thing and then state the reason. So when we use this particular theorem to state a particular result, what is the reason that we use? Here the reason would be what? If we are concluding that OM is perpendicular to AB, someone is going to say, but sir, we don't see that in the diagram. OM is perpendicular to AB. Where did you get that from? Remember, this is a result that has come about because of the theorem statement. What is the reason for saying OM is perpendicular to AB? The reason is found in the diagram. The reason is what? The reason is simply this: line from center to midpoint of chord. Done. Line from center to midpoint of chord. That is why I say OM is perpendicular to AB. It's based on my if part. It's based on the fact that, as the theorem says, the line from the center to the midpoint of a chord, what does it do? It is perpendicular to the chord, that line. All right? So therefore, OM is perpendicular to AB, and this is my reason. Line from center to midpoint of chord. All right, guys, I think those two theorems, they are very critical and crucial at the beginning, all right? And a very important tool that we need to ensure that we have and we have grasped, all right? I think for today, I'm going to hold the theorem part to that. And let's look at some problems that have to do with this particular theorem, and we can see the application of these two theorems, right? And then in the later sessions, we'll unpack them one by one, bit by bit, and then we will see. No, I will, don't worry. Don't worry. I always do most, you know, right? So all in all, in summary, if we just look at these two theorems, just in summary, do you remember what this is? This is called a chord, right? This is a chord. Then since this is the center of the circle, from the center to the chord, that first theorem, what did it say? It said a line from the center perpendicular to the chord. So if you see this, and let's just take different letters today, what can you conclude from this diagram? This is what you are given. You see, when I look at this diagram, I can read what I see in this diagram. This is saying a line from the center. Yes, call me, you have to. You have to. A line from the center perpendicular to the chord. A line from the center perpendicular to the chord. A line from the center, you can see the center. This is a line, it really is from the center. And what do you see? PN is a chord. So a line from the center perpendicular to the chord. What does it do, a line from the center perpendicular to the chord? It bisects the chord. So our statement will be this: PM is equal to MN. But you're going to say, but sir, I can't see that in the diagram. How can you say PM is equal to MN? It goes back to the theorem. The theorem says a line from the center, perpendicular to the chord. What does it do? It bisects the chord. So my statement is based, this statement that I'm writing here is based on my conclusion from the theorem. Okay. A line from the center perpendicular to the chord, what does it do? It bisects the chord. What does bisect mean? It means it cuts this chord into half. What does it mean literally if I'm going to write this down to say, how do I represent that this line has been cut into half? It means PM is equal to MN. That's what it means. All right? Yeah. Or, yeah. All right? I hope that makes sense, guys. And then all in all, what's my reason for saying that? The reason is contained in the diagram. The reason is line from center perpendicular to chord. That's that's the reason. Okay. So if I say PM is equal to MN, I have to provide a reason. In geometry, guys, Euclidean geometry, you have to provide a reason for a new statement that you make when you are doing a problem. You can't just say PM is equal to MN. The question is how? Because I'm looking at this diagram and I'm like, Aibo, how can this guy say PM is equal to MN? I don't see how PM could be equal to MN in any way. But obviously, if I know my theorems, okay, and I know my short acceptable reasons, this is an acceptable reason that you find in the document that is provided by in the exam guideline for Euclidean geometry. This here that I've written down is not just a freestyled reason. This is the reason that they have officially in the document that is used for when you do Euclidean geometry. Line from center, this symbol is used to denote perpendicular. Line from center, perpendicular to chord. That is how we utilize that theorem. Let's look at the other one. The other one was circle. Please, guys. Okay, sorry, let me just redraw that. Okay, bit of excitement there. Okay, I just want to change orientation. Okay, I want to change the orientation because oftentimes you see the theorem like this and people think, it's always going to be like vertical, upside down. No. They can change the orientation. So it's very important for you to be someone who is very flexible. You need to be able to, if you know it in a certain way, you need to be able to turn around your piece of paper, turn it around until you see what you need to see, if you know what I mean, okay? So what I'm going to do, I'm going to deliberately just have this thing like this, okay? So there it is. Let's say O, let's say Z, Y, let's put X here, okay? And let's do this time round. Okay, do you see this one, guys? Do you see this one here? So, this theorem has to do with a line from the center to the, look at this, zx is equal to xy. So this is a line from the center to the midpoint of a chord. What do we know about a line from the center to the midpoint of a chord? What does it do? A line from the center to the midpoint of a chord. What does a line from the center to the midpoint of a chord do to the chord? It is actually perpendicular to the chord. So what would be our statement here? We would say OX is perpendicular to ZY. You look at this and you're like, but sir, I don't see in the diagram the lines being perpendicular. And yes, you don't, because remember, there is a theorem statement which says a line from the center to the midpoint of a chord. How do you know this is the midpoint? It's because you can see that ZX is equal to XY. You can see that by these lines. Two lines here, that indicates equality of XZ and XY. That's something that's given to you. So you can then conclude and say OX is perpendicular to ZY. Okay, that's very important. And remember, guys, we would actually say, if we wanted to, we could say YXO is equal to 90 degrees. Please be very careful about saying X. Remember, this here denotes X, but X is from here to there. So we are being specific about the angle, that's 90. YXO, this is 90. Or OXY, the middle letter denoting the angle that we are referring to. Or we can say OXZ is 90 degrees, or ZXO is 90 degrees. Okay, the reason, of course, will be what? The reason, guys, like I said, is in the diagram. Line from center to midpoint of chord. And this is the acceptable reason that they write in that guideline that I was speaking about. So in your acceptable reason document for grade 11s, there is a document there that you utilize whenever you are writing. Those reasons, they are the reasons that they say are actually acceptable for learners to use. Because even exam, those who mark in marking centers in grade 12 at the end of the year, they utilize these reasons to be able to identify whether learners are answering questions appropriately or not. So it's very important to sort of like make sure that you align yourself with those acceptable reasons, that document for acceptable reasons. So this is the reason why we are saying OX is perpendicular to ZY. All right. So the line from the center to the midpoint of the chord. Okay, that's the reason. OX is perpendicular to ZY. Why? Because you can line from center to midpoint of chord. Okay, so please guys, like I said, we can't just say X is 90. Please, 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 you don't say X is 90. Here, you need to be specific. Remember, 90 degrees. X here denotes the point, okay? And obviously, X here, if you were talking about X in totality here, you can't say X is 90. You can specifically say angle YXO is 90 degrees. Or you can say angle OXZ is 90 degrees. And you make sure you put the cap on top of the X to denote that that is the specific angle you are referring to. Your orientation is important. YXO, that is 90. Yeah. Okay. I hope you guys are with me here about this fact that we can't say X is 90. We need to be specific. So you can say YXO is 90. You can say, if you change your orientation, you can say OXY is equal to 90 degrees. You see, that's very important. You can do that. Or you can say OX, if you look at the other side, OXZ is equal to 90 degrees. Or you can say ZXO is equal to 90 degrees. This is very important to be specific about the angle, all right? Let's not just take for granted and say X, because if you're saying X, remember X, all right? Yeah, it's very important to denote the specific angle. If you do that, then you see, it means you are also very much aware of the diagram itself. Sometimes what they do is they put a nice 1 and 2 for you there. Okay. Now this one, it would have been very easy to just say angle x1 is equal to 90 degrees. Because once they do that for you, then it's easier to just say x1. Okay. But you don't fill in 1 and 2. No, you don't fill in 1 and 2. They must give it to you in the diagram so that you can utilize it. All right. So then it's fine to say x1, angle x1 is 90. Okay. And don't forget the reason. Line from center to midpoint of chord. Because your line from the center to the midpoint of the chord, you know the result is that a line from the center to the midpoint of the chord is perpendicular to the chord. So it's us simply using the result to state why XO is 90 degrees. And please, that reason, so crucial. Line from center to midpoint of chord. So guys, this is me trying to say to you that these first two theorems, very important, guys. Okay, so the first one, like I said, a line from the center perpendicular to the chord bisects the chord. And so I unpacked for you guys what it means when we are saying a line from the center. This is the center. This is a line from the center perpendicular to the chord. Why do we say perpendicular? Because there's an angle 90 degrees formed. Okay? And then the line from the center perpendicular to PN is a chord. To the chord. What does it do, that line? That line, it bisects the chord. Do you see that in your diagram, the bisecting part? No. So you can state the result, PM is equal to MN. That's what bisecting means. That is the result. What is the reason for saying that? The reason for saying that is in the diagram. The reason for saying PM is equal to MN, which represents bisecting, the chord bisecting, is line from center perpendicular to chord. This is the acceptable reason that we use as per the document for acceptable reasons. Then that's the one of the theorems. The other theorem says a line from the center to the midpoint of the chord. A line from the center to the midpoint of the chord. This is truly the midpoint because you can see that xz is equal to xy. What do we know about a line from the center to the midpoint of the chord? The line from the center to the midpoint of the chord is perpendicular to the chord. That's why we can say OX is perpendicular to ZY. Do we see that in the diagram? No, we don't. Is it a result that we get because of the theorem? Yes. So yes, to the person who asked me earlier on, must we know the theorems off by heart? Yes, guys. You need to know the theorems off by heart because once you know the theorem statement, you know what you are looking for in the diagram. You know the result that will come about because of what you see in the diagram. And then the reason, guys, the reason. So please, guys, take you can pull down these posters that you have of Beyonce and all these celebrities that you have there. You need to refurnish your wall with the theorems, guys. You need to refurnish your walls with the theorems because these theorems, they will affect you in grade 11. They will affect you during the June exam. They will affect you at the end of the year when you write your final grade 11 November exam. For the grade 12s, you'll be affected by these theorems when in June, when you write your June exams. Those who are rewriting, they'll be affected by these theorems during the June exam when they write paper 2. When you're writing your actual exam, you'll be affected by this in the trial exam. You will be affected by it during your final grade 12 exams. So you need to make sure that if you are learning this for the first time, it needs to be clear to you what the theorem says, what is the theorem statement, what is the result. And then you need to know the acceptable reason that you are using for each and every one so that you know what you need to do all the time. And once you get that done, guys, and you get that down, geometry is so easy. I remember one of the learners that I taught, I think the first time round when I taught them the geometry, they were like, yo, I said, this is so difficult because it was their first time being exposed to such a thing. Then we redid it again, all right? And he got a chance during the holidays to really, this was like a few years back, to get the chance to really get this, explained a little bit more. After the second time round, he was like, I don't understand why I was complaining about this thing to begin with. And I was like, yeah, well, it's a good thing that you don't understand why you were complaining about this thing to begin with. And he was like, it's so easy. Geometry then became his most favorite, topic, in paper 2. And that's where he seemed to score the most marks because he was just like, hey, this thing is so easy. So yes, guys, know the theorems. Please make it an increased effort to make sure that you do the things that need to be done in order for you to actually start eating the theorems and understanding what they mean. If you do that, guys, you guys will be champs. You'll be like, geometry for who? Geometry for whom? Complain for who? Yeah, I don't know if there's any particular questions that people may have. Any questions about the grade 11? I know that people now are saying that, okay, let's look, I want to look at some questions, a few questions around this particular theorem, okay, because it won't be, it won't make sense if we don't look at some few questions. So we'll look at some few questions around these two theorems, which is very important, and let's see where that will take us. Right, excuse the noise, amazing noise. Okay, let's look at some problems here very quickly. Let's look at some. Okay, I'm going to do a few examples for you so that you guys can kind of see what's happening with these beautiful theorems. So this is a diagram that we have. Okay, we are told here that O is the center. Oh, by the way, this spelling of center here, guys, it depends, right? If you are in America, center is spelled in a certain way. If you are using British English, like we have been colonized by the British, then obviously you're going to have center being spelled a bit differently. So we spell center with the R-E because we know who we were colonized by, right? I think that it has to do with that, of course. So anyways, anywho, so O is the center. Let's look at the statement. O is the center. AC is equal to 8. OB is equal to 3. And OB is perpendicular to AC. So now we need to calculate, according to this, we need to calculate 1, AB, and then 2, we need to calculate OC. So let's see what this has to, how we can maneuver here. All right. So first and foremost, we are given in the statement that O is the center. You can see there is a center, right? AC is equal to 8. So let's just fill that in our diagram. We know the entire AC is 8, right? Then OB is equal to 3. There's 3 there. And then we are told that OB is perpendicular to AC. Now, what we are asked now is to actually find the length of AB. So let's first and foremost look at this. Where's AB? AB is here, from there to there. That's AB. Right? We need to find what AB is. All right. When we look at our diagram, you can see we are already in the diagram told that OB is perpendicular to AC. And we want the value of AB. All right. So from the diagram itself, if we look at the theorems that we've just done, the two theorems, we learned that a line from the center perpendicular to the chord. What happens with a line from the center perpendicular to the chord? What do we know about a line from the center that is perpendicular to the chord? By the way, AC is a chord. I'm sure you guys can see that. AC is a chord. OB is the line from the center perpendicular to the chord. So what result do we know about a line from the center perpendicular to the chord? We know that a line from the center perpendicular to the chord does what to the chord? Surely someone needs to type this. A line from the center perpendicular to the chord. What does it do to this chord? It bisects the chord. In other words, what can we state? Thank you, Cypher. Thank you, Jack. You guys are spot on. So a line from the center perpendicular to the chord bisects the chord. So in other words, we can then conclude and say AB is equal to BC. Ne? AB is equal to BC. All right. And why do we say AB is equal to BC? AB is equal to BC because we know that a line, the reason is contained within the diagram, a line from center perpendicular to chord. Now remember, guys, we were told that AC, the entire AC is equal to 8. So if the entire AC is equal to 8, what does it mean about AB and BC? If AB and BC are equal and the entire length of AC is equal to 8, what is the length of AB, guys? Knowing that OB is bisecting AC. The entire length of AC is 8. All right. Thank you. So that's why we say AB is equal to BC, which is equal to 4. And our reason is very much. Yes, thank you so much, Tibongs. It's half of 8. That's why someone else would actually probably say AB is equal to half of AC. I mean, that's also fine because the half of AC is 8. That means the answer there is 4 units. Okay? I mean, this would be a nice alternative way. So here, what I've just done here is just simply use the algebraic approach. AB obviously is equal to half of AC because this reason is very much applicable. Line from center to center perpendicular to chord. So this one is me doing it off by heart. Okay. Right? And then this one is me sort of like approaching it more algebraically, if you want to say so. Right? But I mean, even if I said AB is equal to BC is equal to 4, 100% correct. I've got my statement, I've got my reason, so it's full marks. Or alternatively, if I'm someone else who's thinking a little bit more algebraically, to say AB is equal to half of AC, that is my understanding that indeed this line AC is being bisected by OB. So if I say AB is equal to half of AC, that's true. Why? Line from center perpendicular to chord. That's why I can say this. So this would be a second option or second approach. Okay, so AB is equal to half of AC. I show the half of 8. I get AB is equal to 4. Both of these would be acceptable. If you answered your question this way, I would give you 100%. If you answered your question using the second option, I would give you 100%. The reason is very critical, guys. You need to make sure that your statement is followed by a reason that makes sense. Okay? I hope I'm flowing with everybody and everybody is flowing with me. Right? So we've answered number 1. The length of AB. AB is equal to BC, which is equal to 4. Reason? Line from center perpendicular to chord. Our reason is in the diagram. Our statement is unseen. I can see your reason. The statement I cannot see. But it comes from knowledge that I've gained about the theorems. That's very important. Let's move on to the next question. Calculate OC. Let's go to the diagram. Where is OC? OC is here. I already know that AB is 4. So I fill in my diagram. I update it so that it has all the relevant things that I know. And obviously that means BC is also equal to 4 because I already stated that AB is equal to BC, which is equal to 4. So there we have it. Now what do we need? We need the distance of OC. Where is OC? Here is OC. What two-dimensional shape is basically making OC is availability, right? So you can see most OBC in triangle OBC. Now I'm simply applying my knowledge that I know from previous grades, because when we did Euclidean geometry in grade 8 and 9, you guys did the theorem of Pythagoras as well as part of the proofs for Euclidean geometry. What does the theorem of Pythagoras state? The theorem of Pythagoras states that the square of the hypotenuse side is equal to the sum of the square of the other two sides. I repeat, the hypotenuse is always the longest side of your triangle. It is always opposite your 90-degree angle. This is called the hypotenuse. OC squared. So in other words, the square of the hypotenuse is equal to the sum. What does the sum mean? The sum means addition. The sum of the what? Of the square of the other two sides. So I've already used OC, which is my hypotenuse. Okay. Then all I simply do is I say OB squared plus BC squared. The reason that I use Pythagoras. Very important. But maybe before you even say that, what would be very important to say before you even say that would be the following. OB is perpendicular to BC. That is given. AB is equal to BC. That's already 4 units. We already established that from the top because we proved that. That's why I say it was proved. So OB is perpendicular to BC. That's given. AB is equal to BC. I know that was proved above. And then I use Pythagoras. OC. What's OC squared? That's what I'm looking for. That's what I want. I want OC eventually, but there's a squared. But we'll take care of that, no problem. What's OB? What's the length of OB? The length of OB is 3. So I substitute the 3. And I use brackets, guys, to substitute, then the square on the outside. What's the length of BC? BC is 4. Right, very good. Alwandle, I love Alwandle. Has already sort of like gone ahead of the game and answered the question very nicely. Mabut, am I right if I say perpendicular to the chord? Perpendicular to the chord. Or as in like you write it out, the reason here, line from center perpendicular to the chord. I guess it's fine. But yeah, the more you can learn to shorten the reason by writing the symbol perpendicular. Just do that, man. Makes life easy. Okay, makes life very easy. All right, request panel. Would you be shocked if I said I don't actually know how to remove the request panel? Okay, there we go. Okay, I thought I couldn't do it, but I did it. Okay, that's there. 3 squared is 9. 4 squared is 16. Okay, we got 25, and obviously OC squared is still hanging on there. We take the square root on both sides. Okay, and remember guys, when we take the square root on both sides, practically speaking, we do write plus minus. Okay, when we take the square root on both sides, we write plus minus, but we know that the length of anything can't be negative. So we know that even though OC is plus minus 5, therefore we can conclude and say OC is actually equal to 5 units. Okay, and as per rule, guys, whenever you take the square root on both sides in an equation, you must ensure that you put that plus minus. It's something that, because you see, the thing is when you're doing other topics, okay, but it's just that for this, you know for a fact that that plus minus, that minus sign won't affect a length, because a length has to be positive. Okay, but yeah, just as a principle, because sometimes people just think that we don't put plus minus, but just as a matter of principle. So OC is equal to 5 units. So whoever said 5 units, you were spot on. You were spot on. And guys, I get all my marks. Like I walk away smiling. I'm like, I walk away smiling very big, not small. I walk away with a big smile. I'm like, this was so easy, done and dusted. No problem. Okay, so let's look at another one. Maybe one that incorporates the other theorem that we looked at. Let's look at this one. Here is another one. So we are told here O is the center. So we are told AC is equal to 16. AB is equal to BC. OA is equal to 17. And we are asked to calculate length of OB. So let's first check what we have here. What we do have here is this diagram. There it is. Here we are, center, center. Dun, 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 dun. Got a B. Got an AC here, A and C. We've got an O. We've got a 17. All right, and that's sort of like about that. I think that's as much as they've given us in the diagram. So they're saying O is the center. So when they say center, there it is, the center. Okay. Then they say AC is equal to 16. So the entire length of AC is 16. So I've just decided to write 16 here. Please, guys, understand it is the horizontal length, the chord's length, not the circumference's length. It is the chord length. It is 16, okay? Then they're saying AB is equal to BC. Then we are told that OA is 17. And then we are told to calculate the length of OB. Now, how do we then proceed in this particular question? So let's look at it. O is the center. This is a line from the center which is supposed to be to the midpoint of the chord. A line from the center to the midpoint of the chord. Why do I know it's a line from the center to the midpoint? It's because, look, AB is equal to BC. That's why I'm saying it's a line from the center to the midpoint. Okay, so I hope so far we are going together, guys. So this means now I have to kick into the other theorem. The previous question was the one that said a line from the center perpendicular to the chord. I used the result for that theorem to basically get the fact that AB is equal to BC. Now this one diagram says a line from the center to the midpoint. Why do I know that it's a line from the center to the midpoint? It's because I can see AB is equal to BC. What can I conclude about that? Okay, and remember what I'm asked to find is to calculate the length of OB. Where's OB? OB is here. So OB is actually part of the triangle. Okay, it's part of the triangle. So on my way to calculate the length of OB, let us start here. I know that the entire length AC is 16. Okay, but what is given to me is that AB is equal to BC. All right, AB is equal to BC. If the entire length, guys, is 16, what is the length of AB? Right, because now I know I want the length of OB. OB is in the triangle. AC in its entirety is 16. But from the diagram, what is given to me is that AB is equal to BC. So AB is equal to BC is equal to 8. Thank you so much, guys. You guys are amazing. It is equal to 8. And the reason for that is that it's given. I am given that, guys. It's information that has been given to me very freely. Because if AC is 16 in its entirety, and I am already told AB is equal to BC, I'm simply using what I've been given to basically find the length of AB. Why am I interested in the length of AB specifically? It's because this triangle, I want to eventually use it, all right? But unfortunately, I haven't been told that this is 90. I haven't been told that this is 90 degrees. But because of the theorem, a line from the center to the midpoint of the chord, what does it do? It is a line from the center to the midpoint of this chord. That means that this line is what with the chord? Maybe you guys can tell me. A line from the center to the midpoint of the chord is what to this line? No, Chris. A line from the center to the midpoint. Remember, when I say a line from the center to the midpoint, already in that statement is the fact that AB is equal to BC. I want the result. What is the result of a line from the center to the midpoint of the chord? I hope you guys hear this different language I'm using here. A line from the center to the midpoint. In this thing that I'm saying, when I say a line from the center to the midpoint, what I'm saying in that is that already in the statement AB is equal to BC, because a line from the center to the midpoint. So when I say to the midpoint, it's like I'm saying the line from the center bisecting the chord. What does that line do? if it's bisecting the chord. The line from the center to the midpoint of the chord does what? It is perpendicular to the chord. So I like what everybody else now is responding and saying. So what then can I say? I can say OB is perpendicular to AC. Why? The reason is contained in the diagram. Line from center to midpoint of chord. Line from center to midpoint of chord. Okay? Yeah, OB is perpendicular to AC. So in other words, if that is the case, then there it is. I can put it in my diagram that is 90 degrees. Okay, I'm updating all of my software, updating my software. Remember, I got 8, there's 8, 8. Now I'm updating my diagram. Just like I would update software so that it can work a bit smoothly. The phone now it can work a bit smoothly, me answering the questions. I am playing in triangle ABO. Now I'm sending the person who's marking my work to triangle ABO. Why am I sending the person that's marking my question to triangle ABO? Because in triangle ABO, I can see now I have a right angle triangle. Okay. Okay. Oh, Tiamo, tell me your live times. Hey, Tiamo, these live times are not consistent, young lady, because the thing is, even now, I didn't know I would go live this morning. It's just that where I am working, it just so happened that I'm not actually having a morning session physically at work. So it allowed me to have open time in the morning, and I just thought, let me just do a live. So I don't have consistent live times because of my schedule that seems to chop and change, too many times, right? So once I can get something stable, especially now in the holidays, I'm working in the holidays, guys. I'm not resting. Like, I'm still going to school. We are still teaching the learners. Most the big marks won't come in any other way. So unfortunately, that's what's the situation. But when things become stable, Siamo, I will drop sometimes. But I'll be posting this in my YouTube channel, so you can always go back and watch it and follow along so that you can keep up from the beginning until the end. I'm very sorry about that. So guys, those were with me in triangle ABO. There we are, triangle ABO. What triangle is this? It's a right angle triangle. What do we want in this right angle triangle? We want OB because we were asked to find the length of OB. Guys, you can go to my link in my bio, and the YouTube channel is called Maths is a Game. Okay, Maths is a Game. Just like the TikTok, it's called Maths is a Game. It's Maths is a Game 5 to 7. All right, so it's got a 5, like in the number 5, and then there's a forward slash. No, sorry, not a forward slash, but a hyphen or a dash if you want to call it that, and then a 7. Okay, but you can go to my bio. There's a link there, the YouTube link. You can click on it. It will send you to the channel. You see, and then you can subscribe there. And the uploads for this video, I'll upload it only later on this evening. This video when I'm in the Wi-Fi zone, because hey guys, data, it's gonna chow me. Okay, so in triangle ABO, now we can go ahead and find what? OB. But we know that we can use who to find OB there? We can use what? Pythagoras, guys. We can use Pythagoras, right? So triangle OBA, we can use Pythagoras in that triangle to find the length of OB. We already have the length of AB. We already have the length of OA. Now we just want OB. When we have one missing side in a right angle triangle, Pythagoras can be used very nicely. So what do we say? The square of the hypotenuse side. What is the hypotenuse? The hypotenuse is the longest side in a triangle. It's always opposite your 90-degree angle. So we say OA squared is equal to the sum of the square of the other two sides. The other two sides are AB and OB squared. And then we write the reason, Pythagoras. Please, guys, we need to write that reason. It's very important to write the reason, Pythagoras. Okay? Please. Then, OA squared, 17 squared. AB squared. AB squared is 8 squared. OB, that's what I want. OB is who I'm looking for. Okay? Then I can go ahead and I can isolate OB by transposing, 17 squared minus 8 squared is equal to OB squared. All right? You can utilize your sweet calculator. You'll get 225 is equal to OB squared. Therefore, most OB, if you take the square root of OB, both sides for your calculation, then you get a nice, beautiful answer of OB, which is 15. Remember, you do write plus minus, but of course, you know that the length cannot be negative, so that means OB is equal to 15. Or remember, if we don't have units, we can write down 15 units, and you make sure that that is the case. So basically, there it is. It's 15, guys. That is how we calculate the length of OB. Okay, grade 11, guys, grade 11. So yeah, that's basically our cycle sweet geometry, guys. This is how we do the things. This is how we sweetly do. All right. Okay. So let me leave you with your own fair share of activity there. Activity 1, activity 2, and so forth. And then yeah, you guys can also check if you guys are able to answer these questions. Yes, Tando. Yes, Tando. Yes. That would be fine, all right? If OA was not drawn, okay, yeah, that would be fine to do so, okay? Yeah, if it was not drawn, especially if they say calculate the length of something and basically they have not provided, you'd be okay to do that, because that would in essence be a radius anyways. Okay, so yes. All right, and I think that's the only situation where you are allowed to actually do that, but don't make it a habit in other theorem problems, because we don't make that a habit. OC is equal to 10. Okay, and OB, thank you, Mbali. OB is perpendicular to AC. Calculate the length of AC. Okay, so I'm going to just zoom out a little bit here so that you guys can see the diagram a bit more. And let's see, guys, you can do this for me. I'll give you some time to actually do this problem. We've got A, we've got B, we've got C. This is 6. So O is the center, OB is equal to 6, OC is equal to 10, and OB, as it says, OB, okay, let's just write O there, OB is perpendicular to AC. Calculate the length of AC. All right, so let me give you a chance to do that one. All right, and remember, where reasons are applicable, you make sure that those reasons, they appear, all right? Because in geometry, that is the thing that basically separates the men from the men. Oh my goodness, okay. O is the center, OB is equal to 6, OC is equal to, OC is equal to 10. Why do I write 16? Yeah, OC is equal to 10, and OB is perpendicular to AC. Calculate the length of AC. So I'm going to give you guys a chance to do this. You guys can do this so that you can actually also check if, you know, for these first two theorems, are you feeling it? Are you getting into the groove of things? All right. And then, yeah, I'll do it when I can see that people can actually confidently say to me that, yes, sir, we've tried it, we've attempted it. Can you just help us out with the corrections and so forth? So let's allow people a chance. O is the center, like I said. OB is equal to 6. OC is 10. And OB is perpendicular to AC. We need to calculate the length of AC. Grade 11, proceed. No, please wait. What do you want me to wait for? Alwande. Thank you guys for the gifts. Yo. Yeah, thank you, Mbali. Thank you. I think today something happened that I haven't had happen in ever. And it's unfortunate that this person kind of came in, dropped that gift and left, I think. Okay, I see there's someone who has finished. Alwande Lupiwe seems like to have completed the puzzle problem. Okay, I'm just gonna give people a few more minutes to do that. The rest, you can do activity 2 as well, and just have a crack at it. The length of AC from someone else is 16. Okay. Bogamos was also saying 16. Okay, I'm glad you guys are actually working. That's nice. It's so good. So refreshing to see. Avomotivo says it's 16. Bogamoso says it's 16. Okay, from our 8. The length of AC was 8 initially. Now it seems like it's upgraded to a number 16. All right. I like the varied responses. Activity 2 is also in waiting there. O is the center, EO is the square root of 3, OF is equal to 2, OE is perpendicular to DF, and then calculate the length of DE. Label gang. Okay. Whew, man, all right. There was a mistake that I've made. Sorry, no problem. Alone, it's no problem. It's okay to make mistakes whilst we are in the process of learning. You know, I'm sure you heard of the yeah. Let me not go into sermon phase, but like it's okay to make mistakes. As long as we rectify those, we learn something from it, and then it makes us better capable next time. Always the same. The question is, call me Lee. Did you work it out? Did you do it? I mean, it's good that you're asking. I will only be able to confirm everything once you guys can say to me that you're done. In the next 3 minutes, I will do the corrections for both of these two activities, and then I'll give you others, and then I have to go. Oh, you did it. Okay. Let's trust. Let's trust. I believe there's definitely there's definitely goodness in what you've done. Yeah. So most of us will probably be able to get answers here. But you see, the thing is, the thing that really gets people off is the reasoning. You see, the reasoning for new statements that you make, right? And sometimes not writing certain statements when you ought to have written them. That's what sometimes leads to a loss of marks. Thank you so much, buddy. That basically is the issue here with geometry. People will have no problems doing the calculations. The algebra will be fine. People can utilize Pythagoras. People can identify equal angles, but then they omit to write reasons for new statements that they make. So for instance, someone will use Pythagoras, no problem. AB squared is equal to something, no, but then forget to write Pythagoras. Because that's a reason that needs to be there whenever you are using Pythagoras in Euclidean geometry. Okay, so someone else will say AB is equal to BC, but they will forget to write the fact that line from center perpendicular to the chord. You see, they forget that thing. You know, they get the right answer, but then they forget the statement with its appropriate reason. So this is what we need to nurture that in ourselves as we do geometry. All right, please let's nurture that. If we can nurture that, then guys, you'll see, man. You'll be like, geometry in grade 11 is so whack. It's so easy. Okay. And it is, guys, it's easy. Grade 11 geometry is easy, ka-peasy, ka-easy, ka-measy, ka-deasy. Think of any other word that rhymes with that and you've got it. All right. Okay, guys, I'm going to do our beautiful corrections. So let's just check out what we have here. So that was the diagram. O is the center, OB is equal to 6. Okay, I think I've given you enough time. Remember as well that it's very important that you guys stay within the stipulated time frame. That's another thing, okay? That we need to work within a stipulated time frame so that we don't find ourselves spending too much time doing a problem that it actually makes us incapable of doing the others, running out of time, and then it's like you did not finish the paper. We can't have that happen, you see. So there needs to be like a level of urgency when we do certain things, you know, not too much relaxed. So when we know our theorems very well, then it's easy to fix the time issue. You know, the time issue sometimes is a matter of not knowing the work. When you know the work, the time issue is able to be sorted, you know. So O is the center, OB is 6, OC is 10, and OB is perpendicular to AC. Calculate the length of AC. So what do we have? We have OC, the hypotenuse. We have OB, the other side of the triangle. And then what we need here to get AC is we just need to know what the length of BC is. Once we know the length of BC, then we will use our knowledge of line from center perpendicular to the chord to be able to get the entire length. Easy peasy. So let's go. Let's start there in the triangle. So we are going to say, the person who's marking me, in triangle OBC, so that the person can have his attention in that triangle. In triangle OBC, that's where I'm working. The square of the hypotenuse side is equal to the sum of the square of the other two sides. Don't forget this guy. You see? Yeah. So maybe someone else would have said, just first write OB is perpendicular to AC. It's given. Okay. It's given information that OB is perpendicular to AC. That basically is the reason why I'm basically going ahead and I'm using Pythagoras, because Pythagoras is only used for right angle triangles. So the fact that OB is perpendicular to AC, and I've acknowledged that, then Pythagoras usage is very nice and sweet. Okay. OC squared. What's OC? OC is 10. What is OB? OB is 6. Okay. What is BC? BC is what I don't know yet, but I'm going to find it out. So I know this is 100, this is 36. We have BC squared. We can transpose the 36. Isolate BC squared. When BC squared is in isolation, guys, then it's very easy to get the 64, take the square root on both sides. we know that BC, because it's a positive length, I'm not even going to bother myself and write the plus minus part, but I'm just going to write the 8 for BC. So BC is 8. 100% spot on. 100. Call me Leo. Okay, but at what stage did you say AB is equal to BC, line from center perpendicular to the chord? It's very important. At this stage, you can say that. Okay, remember what you want now. You want the length of AC. Okay, AC is equal to AB plus BC. All right. But first and foremost, we know we're going to say the following. AB is equal to BC. Why do we say that? Line from center perpendicular to, sorry, let's get this perpendicular sign right. Perpendicular to chord. AB is equal to BC. This is something we conclude based on the fact that a line from the center perpendicular to the chord bisects the chord. Therefore, we know that AB is equal to BC, line from center perpendicular to the chord. So we know that AB is equal to BC. That means we found that BC is 8, so we know 8 plus 8. AC is equal to 8 plus 8, and obviously AC is equal to 16. 16 what? Units. Whoop. Right? Right. Okay, someone else could have said AC is equal to 2 times the length of BC. That's also fine. If it said AC is equal to 2 times the length of BC, that's also fine. I mean, guys, yeah, at the end of the day, we're still rolling with the same thing. Okay, but this statement is very important because this statement with its reason gives us grounds to do the work that I do below. Okay, this statement with this reason not being there for this statement does not give me ground to do anything. So that's why this theorem, you see, we go back at this theorem, line from center perpendicular, the line is perpendicular to the chord. What does it do? The result is it bisects the chord. So don't take it for granted that after this, you get BC is equal to 8, and then you just jumped and you say AC is equal to 16 units. Please, guys, you need to first establish what you learned from the theorem. Someone else could basically say AC is equal to 16 units and just write the reason. That's also fine. But this reason is what gives this answer weight. This reason is not there. There's no weight in the answer. This reason is there. There is weight in what I eventually conclude and do. Are you with me? So I'm very proud of you guys. You know, I even love, look at Call Me Lee said, AB is equal to BC. Beautiful. Line from the center perpendicular to chord. That's 100% fine. Guys, the reason I am using this symbol is because this is short form for perpendicular. If you go to the document of acceptable reasons for grade 11, Euclidean Geometry, this perpendicular can be written in short form as perpendicular. You see? So anything that can actually shorten life, shorten things for us, I will go ahead, we do it, guys. Okay? Definitely. But call me Leo, you didn't be making a mistake at all if you wrote the word perpendicular out. There would be no problem in that. Okay? Okay. Right, we good. Let's look at activity 2. Okay, so my round of applause to all the people that made sure that the reasons were there. You see, you guys, reasons. Okay, OP is perpendicular to AC, that's given. This then gives me ground to use Pythagoras. I write the reason for Pythagoras. Please, guys, don't ever forget, write Pythagoras. Whenever you are using Pythagoras, it's the reason. You get the answer. Then you want to get the length of AC. Obviously, AB is equal to BC, and obviously, you know, AC is actually the two lengths added together, or you can say it's 2 times the length of BC. That's also fine. Okay, works out very nicely. Okay, all right. Dipuzo, questions, fra, mibuzo, anything, any phras, any questions? Dipuzo, mibuzo. I don't know if there's any other way of saying questions in any other language for anyone that's actually on the platform. Maybe you guys can say so, but yeah. You can help me out here. I need to diversify and use the other lingos as needed. Okay. I am Xhosa, by the way, so 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 you can understand me and this guy using Xhosa all the time. Here we are. Look at this one. So activity 2, O is the center. EO is square root of 3. Sorry, did I say EO? Yes, EO is square root of 3. OF is 2. OE is perpendicular to DF. Calculate the length of DE. Where is DE? DE is here. So eventually, we're going to be doing some stuff. But you can see our triangle there, the right angle triangle. Thank you, Katlech. This right angle triangle, you can see, guys, has the hypotenuse is 2. The other side is square root of 3. We must find EF. So we are going to send Mr. Se or Mr. Mem or Mrs. Mem to the triangle. Triangle EFO. That's where Mr. Se or Mem needs to actually look in my answer. In triangle EFO, what is there? In triangle EFO, it is already given to me that OE is perpendicular to DF, and that is very much given. This gives me grounds to use Pythagoras. So I'm going to say OF squared is equal to OF squared, remember, hypotenuse squared. Hypotenuse is always opposite the 90-degree angle, so that is OF squared is equal to what? EF squared plus what? OE squared. Reason, Pythago, Pythago, Pythoda, Pythado, Pythido, Pythago. All right, Pythagoras. Then what is OF? G2 squared, G2, EF squared, what I'm looking for in the triangle for the other side. OE squared, OE, G square root 3, G square. Then I go ahead, 4 is equal to EF squared. Let's isolate 3, take the 3 over, 4 minus 3. I think call me, this is where you actually were spot on. Someone asked me, is the answer 1? It seems like it, eh? Oh, and the square root of 1. Therefore, EF is equal to 1. Okay. IEF is truly 1, but then what do we want? We want DE. So, this triangle, remember, the line from the center perpendicular to the chord does what, guys? The line from the center perpendicular to the chord does what? It bisects the chord. So what statement can I then write? DE is equal to EF is equal to 1. What is the reason? Line from center perpendicular to chord. Line from center perpendicular to chord. Very important. DE is equal to EF, which is equal to 1. So yes, whoever said the answer is 1, therefore ED, was it DE that they wanted? Yes. Therefore the length of DE is 1 unit. Okay. So you're 100% as long as the reasoning, guys, is there. This holds water. This holds water. No reason, you basically lose out on marks. Okay. Any questions? All right. So, new statement, I must give a reason. New statement, I must give a reason. Then my working out, I mean, obviously, this is just a working out. New statement, I must give a reason. You know what I mean? And then this is just the answer. Are you with me? Okay. Guys, hey. Right, I'm going to love and leave you now because I have to. And it's break time where I'm at right now. But I'm going to leave you these to do. And then, guys, I'll just play it like we are playing it. I don't know when the next time will be. Okay. Okay, let me leave you with this problem. So what I have here is DEDO AB. That's a D, okay? And then I'm just gonna write down the statement so that you guys know what the statement is saying. Sorry, I'm sorry, you're gonna hear a bit of noise. AB is a chord of the circle, center O, OE bisects AB. AD is equal to 12 centimeters, ED is equal to 8 centimeters, and OD is equal to X. First question, I need you to determine OB in terms of X to calculate length of OB. Right. Okay, so I think that's one question you guys can actually do. And then the other one, I think the last one would be this one. Okay. And I'm sure you guys can see, I first gave you first two activities had to do with the line from the center perpendicular. Now I'm giving you two activities where it's line from center to midpoint. Why? Because I want you to be able to hammer in the two concepts, all right? And I'm going to leave you with those, and then it will be up to your own device to actually make sure now that if you want to become even that much more solid when it comes to these concepts, you need to actually practice and find more problems so that you can be able to get it. Chris Tando, you're saying on the calculations for DE, what's happening? I don't know. I'm kind of a bit lost there. Okay, there we have it. Just going to remove the comment sections a bit so that you guys can see the full without the interference of like what you're seeing on your page. So there it is, so that people that need to screenshot can screenshot, because I'm going to have to close the live very soon. But guys, thank you so much. It was epic, amazing. You guys were very patient. Like I said, this was very random. It was not really planned. Like literally, this was not planned. Trust me, when I woke up this morning, I did not know that during this time period I would be doing Euclidean geometry. This was obviously someone's request. We actually gave that request a chance, and then the chance of the request yielded this sort of work that we are now doing. And hopefully this has really helped some of you. All right, I will definitely be continuing on with the geometry. okay, because this is basically the first session of the grade 11 work. This is like the first two theorems that we've covered. The theorem that says a line from the center perpendicular to the chord bisects the chord. That was one of the theorems. And then the second one was a line from the center to the midpoint of the chord is perpendicular to the chord. So all in all, these two theorems, we need to know them and we need to be able to apply them. Okay. Please invite us to come. Dibongs Bongega. Hopefully you have followed me, and also like I think there's a way of you getting notified whenever I do a live. So just make sure that you have switched on whatever notifications need to be switched on in order to be able to be part of the live session the next time. And yeah, thank you so much for your patience. It was really nice. It was sweet. I actually thoroughly enjoyed it. It actually just it brought to remembrance some certain things that I also feel like are very important. You guys have a great day. And yeah, like I said, use the knowledge that you've now gained. Do these exercises, see what you can do. And then definitely the next time what I will do is, even if, let's say, for instance, because of maybe the time that I decide to do the live, you may have not been able to join. What I will do is I'll be posting the sessions that I do on my YouTube channel. And I'll basically label them that this is the live session I did in the morning of this time and on this date, and it was Euclidean geometry, so that people can follow along which live session was posted when. Thank you so much. Otherwise, you guys were epic. You guys were amazing. I really appreciate you, everyone, and all the people that gifted very generously. I really appreciate it as well. It's never expected, but when people do it, it's like, wow, thank you guys. Have a great day, and yeah, maths is a game. Play it. The more you play it, the more easy it gets. It becomes really easy, guys, the more you play this game. It's like you're like level 7, popping all the time, you know? Yeah, thank you so much, guys. Have a good one.